Hi, this is Tim from Tiger Astronomy and you're watching Adventures in Arduino. Hi, welcome back to episode 2 of Adventures in Arduino. In this episode we'll talk about a library also written by Tiger Astronomy called the Cadenced Indicator, and a cadence is just a pattern that repeats over time. So this is typically used for making fancy LED indicators. So you can see that I've already done File New Project, and the Platform.io has put in the basic framework for us, and also I've updated my platform.io.ini file already, and I've got the Maker Wi-Fi 1010 target that we had in the last episode, and I've also added again the Mega 2560 target. So these are just show you these boards on the desktop here on my workbench. This is the Mega 2560. This is actually a Wi-Fi edition because it's got built-in Wi-Fi, but we won't be using that for this example, so we can just ignore it. This is the Maker 1010, also with built-in Wi-Fi, and I've removed all the code from these boards, so they're not doing anything at the moment. And if we go back to the platform.io.ini, you notice that I've set my default environment to include both of the boards. So the Maker Wi-Fi 1010 uses the Atmel SAM platform. Now this is an ARM core, Acorn RISC machine, and is a 32-bit CPU. And the Mega 2560 uses the Atmel AVR core, which is an 8-bit CPU. So it has plenty of memory and flash ROM, but it's still nevertheless an 8-bit CPU. Okay, so let's add our library. So we're going into the Platform.io libraries screen, and we can search for ta.arduino again, and we have the timer library, and now we have Cadenced Indicator. So we can go ahead and add that to our project, and it is the Cadenced Indicator demo that we're using. So add, and that will install the library in the correct place as before. We can just build all now, I think, so let's just try that. Let's make that full screen. And notice that it's picked up the fact that the Cadenced Indicator library depends on the timer library, and it's configured everything there for us automatically. Now these yellow warnings are something to do with the framework, which is nothing to do with our code. Everything does compile okay. It's a bit disappointing to see warnings, but there's nothing we can do about it, so we just have to live with them. Okay, now we're processing the Mega 2560. Now notice there's an extra library in here. It's detected a dependency on Arduino STL, and we'll talk about what that is in a moment. Actually, we'll talk about it now whilst the build's going ahead. The STL is the C++ Standard Template Library, or STL. Now, the Maker 1010, being an ARM core, has a full C++ library which includes the Standard Template Library, which is why that wasn't detected as a dependency for that target. On the Mega 256, which uses the 8-bit Atmel AVR core, there is a perception that the Standard Template Library takes up too much memory for the smaller processors, and that is true to some extent, although I have used it with some success even on Arduino Uno. So there are pros and cons to that, but I tend to use it in my code because it's very, very useful. So on the Mega 2560 target, we have to have the Arduino STL library available to us. Now PIO has taken care of that automatically because it detected the dependency. and has installed that library for us automatically. So everything builds, and unfortunately it does generate a lot of these yellow warnings, but as I say, everything does compile and we don't really have to worry about it. So back to our main.cpp. Let's close these terminal windows and the PIO homepage. Okay, so main.cpp. Okay, so how do we use this library? It's very, very, very simple to use. It was designed that way deliberately. So we hash include the library header. So that will be cadenced indicator.h. And then we need two things. We need a cadence manager and one or more indicators that we wish to manage. So the first thing we need to declare is our cadence manager, and we're going to call it the LED manager. Okay, and we'll just leave it at that. And then we need an indicator to represent our built-in LED. So we will new up an indicator. We'll just call that built-in LED. And then we need to initialize this with some values. So we're going to use constructor to do this. So when you declare a variable like this in open brackets, you're calling the constructor, and so we need to tell it which LED or which output specifically that we're going to use and what pattern we want it to switch on and off with. So we'll use LED built-in, a predefined symbol for that, and for the pattern we need something of type cadence pattern, and the cadenced indicator library defines a number of predefined patterns that we can use. So we'll drill down into the cadence namespace, and : is the scope resolution operator, which allows you to specify a particular scope or namespace. And so as you can see in the list here, we've got a few predefined things that we can choose from. So I'm going to choose heartbeat, and that's all we need to do. We need to associate the indicator with the cadence manager, and we do that by saying LED manager dot add indicator, and then we pass in a copy of the indicator that we wish to associate with it. Now this you can only add indicators. There's no way to remove them once they're added. You should only add an indicator to one cadence manager. The assumption is that you will be doing all this in the setup method once at the start of the program, and then everything will be left alone thereafter. So this is a one-off, a one-shot thing. And also I've noticed that okay, so the cadenced indicator library will automatically set the pin to an output pin for you, because it presumes if you are going to be switching it on and off, it will need to be an output pin. But however, it's best to do everything explicitly, because you don't want to be programming by accident. So LED built-in will be an output, just so. Okay, and then we need, in our loop, we need to call the cadence manager to allow it to do its updates. So that's just as simple as saying LED manager dot loop, just like that. Okay, now we will upload all, and that will build the code, and the maker 1010 is going first. So we'll be looking just here. There you can see the code loading, and now the program's running, and you see the double heartbeat. Okay, blip blip, there it goes, the double heartbeat's working. All good. And meanwhile the Mega 2560 version is building, and the LED is here. You can see the code loading, and there's the double heartbeat. Blip blip. Okay, so that is what Cadenced Indicator does. It flashes LEDs in various patterns, and there's a number of predefined patterns you can choose from. So we can, for example, let's just minimize that screen. We can, for example, instead of using heartbeat, we could use blink fast, and then if I just I'm only building the Maker Wi-Fi version here just to save a bit of time, and I will upload that. And again, we've still got the double heartbeat at the moment here. Code's loading, and there we go. Now we have the LED flashing in the blink fast cadence. There's also blink slow and blink alarm, and various others that you can choose from. Now if we look at the cadence type, I'm just holding down Control, which makes that a hyperlink, and click it, and that takes me to the file that's defined in, and you can see that these are defined. Okay, so we've got using cadence pattern equals unsigned long, so they are 32-bit unsigned long integers, and then we've got we define a namespace called cadence, and then we use const expressions to define the patterns that we need. So const expression of type cadence pattern steady on equals 0b, which means a binary constant is to follow, and then 32 bits of pattern, in this case it's all ones, and then ul at the end to mean it's an unsigned long 32-bit integer. Okay, now the heartbeat pattern here, line 36, you can see the pattern, it's all zeros, and then at the end it's 1010, so that gives you the blip blip pattern. Okay, and the other one we used was blink fast, so it's like on for 4 bits, off for 4 bits, on for 4 bits, off for 4 bits, and so on all the way to the end. And the interesting thing about these is just because they're unsigned integers, you can use binary operators to combine them in various interesting ways. So for example, you notice there is a heartbeat, which is all zeros and then blip blip at the end. And we've also got something called offbeat, which is blip blip halfway through and then all zeros for the rest of it. So if we were to combine these together with a binary OR, we would get blip 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 blip, so we would get the heartbeat twice every cadence period. And by default the cadence manager runs through this pattern once every 4 seconds, so each bit's about I think it's 120 milliseconds, something like that. So there's 4 seconds worth of data there. So we can, in main.cpp, we can do this. We can put this back to heartbeat, and then we can use the binary bitwise OR operator and OR that with offbeat, just like that. So that's combined those two cadences together, and then if we build that on the Mega 2560, and that's just taking a while to load, and so we upload that to the Mega 2560. Now you notice that currently we've still got the double heartbeat going, and there's the code loading, and now we've got heartbeat is happening twice every 4 seconds, as you can see. So those two cadences have been combined, and you don't have to use a predefined cadence. You can actually make any kind of cadence you want in here. So for example, we could say 0b, we'll go with off for 4 bits, on for 4 bits, off on for 4 bits, and then we'll go off for 4 bits, and then we'll go on for 8 bits, and off for 4 bits. I think that's 32 in total. So we should get on, off, okay. So we'll have a go with that. I will upload that to the Wi-Fi 1010. Away we go. And because that is an unsigned 32-bit integer, which is the correct type of data for a pattern, that should work. And it has... Yep, that's working. Okay, so you see here, on. Okay, so short, long. Okay, so hopefully you can see how these patterns work. One other thing that's worth looking at is there's an optional constructor parameter to the Cadence Manager. Now normally if you don't do anything here, if you just use the defaults, it runs the cadence over a 4-second period, but you can specify a timer duration here. So you can say, and remember this is using the timer library that we covered in the last episode, so we can use timer namespace seconds, and we can go over 2 seconds instead of 4, so it should be double the speed. So we've got the 2-second version running here, we've got the 4-second version running here on the Maker 1010, so we'll put this one onto the other one for comparison, onto the Mega 2560. And that's building and compiling, and it's linking and it's uploading. Okay, so here now we've got the same pattern. Okay, short, long, short, long, and on this one we've got the pattern short, long, short, long, but this one is now double the speed because this is running the pattern over 2 seconds and this is running the pattern over 4 seconds. Okay, so we don't recommend going any faster than about 1 second because otherwise you make too much demand on the maintaining consistent timing. It gets less useful. We think 4 seconds is probably an excellent default. So I'm going to put that back to the default, and remember to delete those brackets, otherwise that won't compile. And I'm going to put this back to cadence heartbeat. Okay, so that's a really simple way of getting a fancy flashing LED indicator, and as your code runs you can change the cadence. So you can use for example, you could say built-in LED dot set cadence. I believe there is a method called set cadence, and then you could say cadence, I don't know, blink alarm. If you had if some error happened, you wanted to indicate an alarm condition, you could set your cadence to blink alarm, and that would just automatically update and work as you expect. So you can update the cadences whenever you like. You just can't take them out of the Cadence Manager. And if you wanted the LED to go off, you've got steady off and also steady on, which just keeps them on all the time or off all the time. Okay, so you can build up some quite sophisticated status indicators just using LEDs like that. Okay, so hopefully that's all sensible, and I find that library extremely useful. I've used it in a number of production products that are for sale commercially, and I think it works very well. So that's the end of that. Thanks for watching. I've been Tim from Tiger Astronomy. Thanks for watching, and goodbye.